Okay, so these are our really quick notes over categories of atoms and molecules. So you see here, this is an atom, and we can pretend this is a carbon atom. So an atom is a single unit. It's the smallest unit of matter that retains the properties of the element. So that's an important distinction. It is not just the smallest unit of matter. It has to retain the properties, otherwise it doesn't count. If you break it down into a gluon or a boson, those don't have the same properties that carbon does. Okay, these are what they are: pure substances, and they are elements only. You cannot have an atom of carbon dioxide. That's not how that works. Okay, so these are a pure substance and they only apply to elements. All right, so molecules are two or more atoms bonded together. That's our definition of a molecule. You can have a pure substance molecule. So let's say this is a carbon and a carbon. This would be C2. And this is a molecule, but still a pure substance. Okay, it has to be all the same element. Lots of elements come in pairs just naturally. So some examples of those things would be O2. Always in nature, it's always O2 because it just naturally wants to bond with itself. Naturally occurs in nature. Okay. So then over here, we have, this is what we call a compound, which is two or more different elements bonded together. Okay, so in this case, we still have our C here, but now we have this O. So that would make this a carbon monoxide, is what this is. So some examples would be H2O, CO, CO2, CH4. Anything that has two or more elements bonded together. And this is not a pure substance. These are not things that you can find on the periodic table. These two can be found on the periodic table. This one's not on the periodic table. Okay, so we have atoms, and then we have two types of molecules: our pure substance molecules, and then our compounds, which are two or more elements bonded together. So there's a definition down here that you need to know, which is homogeneous, which is molecules evenly distributed. So homo means the same. I hope you remember that from biology. And an example would be a glass of water. That's a homogeneous mixture because it's all water. So when everything is the same and it's evenly distributed, that's a homogeneous substance. So up here, this one is homogeneous. This one's just a single unit, so you can't really be homogeneous with that one. All right, so you're gonna go ahead and tape this on whatever page that I told you to tape it on the website or on Google Classroom, and then watch the next video about mixtures.